Good day, students. Welcome to our lesson this week in General Mathematics. In this session, we're going to discuss inverse of a function. For the definition, if f is a function consisting of ordered pairs x, y, then there is a relation called the inverse of f, whose elements are the ordered pairs y, x. The inverse of a function is not necessarily a function. If f is 1 to 1, then the inverse of f is called the inverse of a function f denoted by f negative 1 or f to negative 1. So we can read this as f inverse. So take a look at the figure. So for the relation of the elements or the dominant range of f and then the f inverse, so the elements are interchanged. To get the inverse of a function, we need to follow these steps. So for number one, step one, let y equals f of x. So sometimes g of x, h of x, and any other representation of function is given. Step 2, interchange x and y. Step 3, solve for y in terms of x. And for the last step, change y to f inverse of x. Example 1, find the inverse of f of x equals 4x minus 3 all over 5. So for the solution, so the first step is to change f of x to y. Step 2, interchange x and y. So as you can see, the function y equals 4x minus 3 all over 5 became x equals 4y minus 3 all over 5. The y became x and the x became y because x and y were interchanged. Then let's try to solve for y. So cross multiplication, 5 times x equals 5x. So 5x equals 4y minus 3. Then by symmetric property, we write it as 4y minus 3 equals 5x. Then solve for y. Transpose negative 3, that will be 4y equals 5x plus 3. Divide both sides of the equation by 4. So we're going to get y equals 5x plus 3 all over 4. Then finally change y to f inverse of x. So we're going to get f inverse of x equals 5x plus 3 all over 4. And that's the inverse of f of x. Example number 2, find the inverse of f of x equals 1 plus square root of x minus 2. So for the solution, change f of x to y. That will be y equals 1 plus square root of x minus 2. Then interchange x and y. It will be x equals 1 plus square root of y minus 2. Then solve for y. So transpose 1 to the other side of the equation. So it will be x minus 1 equals y or square root of y minus 2. Then square both sides of the equation so that we can eliminate the radical sign. So that will be the square of x minus 1 equals y minus 2. So by symmetric property, we interchange it so that y will be on the left side of the equation. So that will be y minus 2 equals the square of x minus 1. Then transpose 2 or negative 2. It will be positive 2 on the right side of the equation. So now we have y equals the square of x minus 1 plus 2. Then lastly, change y to f inverse of x. So f inverse of x is equal to the square of x minus 1 plus 2. So that's the inverse of f of x here in example 2. For example 3, find the inverse of g of x equals x squared minus 3. So for the solution, change g of x to y. We're going to have y equals x squared minus 3. Then interchange x and y. We'll have x equals y squared minus 3. Then interchange by symmetric property, y squared minus 3 equals x. And then transpose negative 3, it will be positive 3 on the right side of the equation. So this will be y squared equals x plus 3. Then get the root of both sides of the equation. So the square root of y squared equals the square root of x plus 3. So that will be y equals square root of x plus 3. Then change y to g inverse of x. So g inverse of x is equal to square root of x plus 3. So that's the inverse of g of x. So for inverse functions, let f and g be functions of x if f of g of x equals x and g of f of x is equal to x, then f of x and g of x are inverses of each other. So for example 4, check if f of x equals 7x plus 18 all over 2 and g of x equals 2x minus 18 all over 7 are inverses of each other. So for the solution, so remember the concept of composite functions. So here, g of x became the domain of f of x. So we use 7x plus 18 over 2 and change x to 2x minus 18 all over 7. That's why we're going to have f of g of x equals 7 times 2x minus 18 all over 7 plus 18 all over 2. Then 7 will be eliminated because it's equal to 1. 7 over 7 is 1. So this will be f of g of x equals 2x minus 18 plus 18 all over 2. So negative 18 plus 18 is 0. So that will be f of g of x is equal to 2x minus 2. So 2 over 2 is 1. That's why f of g of x is equal to x. Now let's try g of f of x. So this time f of x is the domain of, or became the domain of g of x, and then we're going to have this because x will be changed into 7x plus 18 all over 2. So this will be 2 times 7x plus 18 all over 2 minus 18 all over 7. So 2 divided by 2 is 1. We're going to have g of f of x is equal to 7x plus 18 minus 18 all over 7. 18 minus 18 is 0. So we'll have g of f of x equals 7x over 7. 7 over 7 is 1. So we also have g of f of x equals x. So both are equal to x. Therefore, f of x and g of x are inverses of each other. Let's have another example. Check if f of x equals negative 2 over x minus 1 and g of x equals negative 2 over x plus 1 are inverses of each other. So let's get f of g of x first. So it is equal to negative 2 over 2 or, negative 2 over x plus 1 minus 1. So there's a complex fraction here. So return to the concept of complex fractions or simplifying complex fractions. So they are both negative, the numerator and the denominator, so they practically cancel each other out. So we have here f of g of x equals 2 times x plus 1 all over 2 minus 1. So 2 divided by 2 is 1. So simply it will become f of g of x equals x plus 1 minus 1. 1 minus 1 is 0. So f of g of x is equal to x. So let's see if we're going to get the same result for g of f of x. So that's equal to negative 2 over x minus 1 plus 1. So in the denominator, negative 1 plus 1 is 0. So that will simply be like this. G of f of x equals negative 2 over negative 2 over x. So again, the numerator and the denominator are both negative, so they cancel each other signs out. So and then remember for the division, so change the operation to multiplication, then express the denominator as its reciprocal. That's why this will be g of f of x equals 2 times x over 2. So 2 over 2 is 1, so we're going to get g of f of x equals x. So both results are x, thus f of x and g of x are inverses of each other. For number 6, so check if f of x equals 2x plus 1 and g of x equals 1 minus x over 2 are inverses of each other. So let us get f of g of x first. It's equal to 2 times 1 minus x over 2 plus 1. Distribute 2. That will be f of x or f of g of x equals 2 minus 2x over 2 plus 1. 2x over 2 is simply x. So f of g of x equals 2 plus 1 minus x. F of g of x is equal to 3 minus x. So it is not equal to x. So let's see if g of f of x is not also equal to x. So g of f of x equals 1 minus 2x plus 1 all over 2. Okay, so let's combine this into a single term or fraction. G of f of x equals 2 minus 2x plus 1 all over 2. So because the LCT is 2, and just simply distribute the negative or the subtraction symbol. That will be g of f of x equals 2 minus 2x minus 1 all over 2. 2 minus 1 can be combined, which is 1. So we're going to have here g of f of x equals 1 minus 2x all over 2. So since both results, f of g of x and g of f of x are not equal to x, so we can say that g of x is not the inverse of x. Or the other way around, f of x is not the inverse of g of x. So for the graph of inverse functions, the relationship of the graph will be observed for all one-to-one functions because it is a result of the function and its inverse swapping inputs and outputs, or domain and range. This is equivalent to interchanging the roles of the vertical and horizontal axes. So as you can see, the graph of a function and its inverse are symmetrical to each other. You can make use of the Symbol Lab or GeoGebra graphic calculator to graph the function and its inverse and observe the behavior of the graph. So here are your practice exercises for this week. For items 1 to 9, find the inverse of each function. And for items 10 to 15, check if f of x and g of x are inverses of each other. So if you have an extra time, try to use the GeoGebra graphing calculator, plot the functions, and observe the behavior of the graph. Those functions are inverse with each other, their graphs are symmetrical. Okay? So class, always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy. God bless everyone. See you next week for our next lesson.